On today's episode, is there an alternative to diesel fuel? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. Many of you responded to my recent episode of End of the Line titled, "After 125 years, diesel may be dead," and some viewers agreed and some disagreed, and thanks to all for the comments. Now, the primary reasoning for those that disagreed was that global warming is not as serious a problem as is widely assumed, and that there is no good reason to kill off the diesel engine. Now, as I mentioned to those viewers, from an engineering standpoint, there are no politics in the replacement of diesel engines. There is a very powerful political incentive worldwide to reduce and eventually eliminate the use of fossil fuels. In the form of penalties and subsidies, that political incentive motivates motor vehicle manufacturers and consumers to design, build, and buy vehicles powered by something else. Now, as I'm speaking to you now, there are diesel fuel shortages in many regions in America. Prices are high. But regardless of global warming or environmental issues, there are key aspects of this kerosene-type fuel system that most people don't know but are important. Now, the first is pure engineering. From an energy perspective, the heat of combustion of diesel fuel versus gasoline is almost identical, but diesel fuel is more dense than gasoline, so if you're buying it by volume, which most people do, diesel fuel offers about 10% more energy per gallon or liter. Now, diesel engines themselves operate with much higher compression ratios compared to gasoline engines with very high combustion temperatures for better thermal efficiency, combined with a long cylinder stroke, which gives the engines ample torque. Even better, diesel fuel is easier to refine from crude oil compared to gasoline with a lower boiling point, and it can be distilled in relatively simple, often older equipment. As a result, small independent refinery operations can readily produce diesel-type fuels for local consumption or for tanker load transport into global spot markets. Now, China has many of these so-called teapots, and although the industry is tightly regulated in that country, they are permitted to operate because they provide vital swing capacity to make up periodic shortfalls and to moderate prices. For major producers, however, efficient refining means large, expensive operations that are tuned to specific grades of crude oil, meaning diesel fuel prices can disconnect from global crude oil prices if the input grades needed by local refinery operations are not readily available. Now, it's technically possible to convert refineries to make diesel from other crude oil grades, but it's expensive and time-consuming, and such a conversion may only be ready to produce sellable fuel into a market which may be glutted by the time production resumes. Then we add regulation. I don't mean regulation on the petroleum industry, but specific regulations on fuel quality such as sulfur content. In North America and Europe, very low sulfur diesel fuels are essential to preserve the complex selective catalytic reduction emission control systems in road-going diesel engines, which means production is restricted to larger, more capable refiners. This diverts the flow of older technology fuel from those teapots and from large, older refineries into regional or third-world markets with complex results for global markets. For road-going use, however, diesel engines are going away for multiple reasons. One is environmental regulation, another is cost and availability of the fuel, but I think the most overlooked one is the engineering of gasoline engines. With very advanced spark ignition combustion chamber design combined with computer-controlled direct injection with multiple injection events, the thermal efficiency of gasoline engines is high enough that they can deliver much of the benefit of diesel engines at similar engine assembly costs, with emissions that are easier to aftertreat compared to diesel engines. Spark ignition engines running on gasoline require no urea injection or particulate filters. A sure sign? General Motors has dropped the diesel engine option from their small pickups because the four-cylinder gasoline engines produce ample horsepower and torque. For motor vehicles, it's possible that we may see diesel disappear entirely. For large ships, the rational alternate technology is nuclear power, as has been used on naval vessels for almost 70 years. For trains, electrification is already a mature technology, and as battery technology improves, I expect locomotives to switch away from diesel power as well. But up in the air, well, there really is no substitute for kerosene-type fuels. Hydrogen is unlikely to prove practical for commercial jet operations, and unless something radical develops, I don't expect aviation to switch in my lifetime. But there is a possibility called quantum nucleonic reactors. It was studied a decade ago by the US Air Force, but very little has been heard about it since. And when a program goes black, it can often mean that it's a workable technology. Well, that's it for today's episode of End of the Line, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For our deeper engineering video series for the manufacturing professional, visit engineering.com TV to watch exclusive shows like Manufacturing the Future, not found here on our YouTube channel. The link is in the description below. Thanks for watching.